Hello and welcome everyone. I hope you guys are doing well there. Today we meet again. We want to look at the hyperbolic function once more, but we want to have a look especially at this given example. It says given gx is equal to 3 over x plus 2. That is our hyperbola. So we are given this function g of x is equal to 3 over x plus 2. So this is actually represented on this graph here. We have our y-x Cartesian plane and we have our 3 over x plus 2. Okay, so what are they saying? They're saying determine the equation of the asymptotes. By the way, we understand what asymptotes are. Asymptotes are actually the lines for which this graph approaches, but they're never going to touch. For instance, in this case here, if I can take you back a little bit backwards, my graph y is equal to 1 over x. I always want to start by referring to the mother graph. This is our mother graph. It means our graph, this is our y, this is our x, our graph is trying to touch the x-axis, but it's never going to touch that. And also, it's trying to touch the x-axis, the y-axis, but it's never going to touch that. So, to answer that now, this graph here has been transformed into that graph, because last time we said y is equal to 1 over x can be transformed into 1 over x plus q, where a is enlargement and q is a vertical shift. So there's a vertical shift. You can look at this graph. It is actually this graph, the original graph, which has been shifted q units up. So in this case, it's q units up. Our q is 2. This one is 2. So it has been shifted 2 units up there. That's where we have our 2. Now, coming back to our question, it says determine these asymptotes. So our solution for our asymptotes, it means we want this we are no longer fixing our attention on this one now. This was just to illustrate from the beginning. We want to come back to this graph, but this asymptote is this line which on this case here the graph is not going to touch the x-axis. So in this case our asymptote is x is equal to 0. But now we have shifted the asymptote 2 units up, so our asymptote is x is equal to x is equal to here is y is equal to 0, y is equal to 0, here is y is equal to 2. This is our asymptote, y is equal to 2, and here y is equal to 0, which is also the x-axis. So we once again, we do have two asymptotes. The first one is this one here, where the graph approaches the horizontal axis, but never touches. And then the other one is this line here, where the graph approaches the vertical asymptote, but never touches. So what is our vertical asymptote here? It's x is equal to 0. So x is equal to 0. So these are the two asymptotes that we have. Y is equal to 2 and y is equal to 0. And this was part A. Part B, equation of the axis of symmetry. Equation of the axis of symmetry. Once again, I'm always bringing the mother graph for the sake of explanation. Axis of symmetry is if I have graph of y is equal to 1 over x, which is a mother graph, the axis of symmetry is either this line, these two lines. These two lines, they split the graph into two equal halves. Let me start by this line here, axis of symmetry. You can see it splits this graph into two equal halves, this one and this one. So y is equal to minus x, this one. But I can also have another one, that one, which is y is equal to x, y is equal to positive x. So the axis of symmetry that I have here is y is equal to x and y is equal to minus x. This one sloping to the left hand side is a negative gradient, and this one sloping to the right hand side is a positive gradient. This is the mother graph. But when we come here, we can see that what has only changed is this value of q, because we have shifted this graph 2 units up, so we have shifted this graph 2 units up here. So it means everything was the same except that the q here is coming into play. So the q is 2 here and the q is 2 here, because I'm adding the graph 2 units upwards. But I'm not going to write my 2 here, I'm going to write my 2 here, because this is where x is equal to x plus 2 and y is equal to minus x plus 2. So when we say y is equal to x plus 2, it means we are looking at this one, x plus 2. Plus 2, it means we're shifting it upwards. So our axis of symmetry is this line here, which is y is equal to x plus 2 units up, because this graph has been shifted 2 units upwards. And then we also have this here, it is y is equal to minus x plus 2, like that. So these are the equations of symmetry. Equations of axis of symmetry are y is equal to minus x plus 2 and y is equal to x plus 2, like that. And now let's have it. That is it for B. That is it for part B. And next we're going to look at part C, values for which G is decreasing. I'm going to erase this part of the board and say let's continue with our C. Values for which G is decreasing. This graph, as you can see here, to the left hand side, all the values are negative. So as I move from here, from 0 all the way to the side, my graph is getting negative, smaller. So G is decreasing for values like x is a member of from minus infinity up to 0. What do I mean by this? I mean all these values as we go to infinity, starting from 0. From 0 all the way to infinity until the end, this graph is getting smaller. It's decreasing. It's decreasing because these numbers here are getting smaller and smaller and smaller. Okay, so this is it for part C. This is how we write our notation. G is decreasing for x being members from minus infinity up to 0. Then let's have a look at D, the domain and range. For the domain and range. Okay, now we want to talk about two very interesting words, domain and range. Most of our learners, they find these words a little bit confusing, but let's try and explain what they are. When we mean, we're going to start by saying domain. Okay, when we mean domain, we look at the y values. For in this case, let's say the y values, we are going to say for the y value, pardon me once again, I was also trapped up in that confusion of domain and range. So, okay, so domain, we talk about the x values. So from x values, our x values on a number line, all the numbers that are on a number line, x here is going to the negative, x here is positive. For the x values there, we are talking about the domain, okay? But in this graph here, we are going to find that this graph here is our graph increases or decreases. It doesn't touch this line here. X values 0 does not, our graph does not get to 0. So therefore, we're going to say, yes, our domain is all the values on the number line, is a member of all real numbers, but except for this, x is not equal to 0. Our graph is not here. Okay, that is it. And then our range is y values. So when we say range is y values. So once again, you find that if I draw this graph like this, yes, the values of the graph is going upwards, the y-axis, and also if I come here, I also find my y values also. So y is a member of all the real numbers except for 2. Here I wrote x is equal to 2. It's supposed to be x is not equal to 2. It means, yeah, let me say y is not equal to 2. It means this graph 2, y is equal to 2 is not part of our graph. So that is basically what we have in this video. I hope you guys enjoyed this video. Stay tuned for more. Hope to see you in the next cheers.